Welcome to another installment of Spring Tips. In this installment, we're going to look at how to do testing and TDD. We're going to look at it in terms of course, the features in Spring Boot. So we'll start with a new project that starts at spring.io. Now, we're going to follow the 3 rules of test-driven development, which I've seen best explained by Bob Martin. Bob Martin says that there are 3 rules when doing test-driven development. So 3 rules of TDD, Bob Martin, and you find this conveniently useful blog. And the first rule is you're not allowed to write any production code unless it is to make a failing unit test pass. The second rule is that you're not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. And third, and finally, you're not allowed to write any more production code that is sufficient to pass the one failing unit test. So basically, don't move too far ahead, right? You're going to keep in a cycle, keep in a loop. As you write a test, you should write the production code that makes that test pass, and then once you've written just enough to make that test pass, you go back and write more tests, and you don't write any more tests than to make the production code fail, right? So it keeps you in a cycle where you're constantly going back and forth between production code and test code and test code and production code, you know, ideally you shouldn't spend more than say 30 seconds long on any one particular thing, right? You're gonna constantly be in this loop. The results of doing this, the effect of moving to this, are manyfold. First, you end up writing software that is testable, right? That's the most important implication of this. By writing software that is testable, you have to force the code to be compartmentalized, to be easily modularized, right? The boundaries, the seams of collaborating objects have to be clearly demarcated, because that's the only way you can mock out different layers of the application, right? You can mock out these pieces that you don't care about by substituting dependencies with mocks. And so, of course, that lends itself to inversion of control and dependency injection, the very basis of all things Spring. Another benefit of moving to this architecture, to this approach, of course, is that when you write software, you get a dopamine hit. There's a dopamine hit associated with achieving or accomplishing something. When you write software that is working and then you write the test, it's not very satisfactory, is it? It feels like you've had to do a chore. You went back and wrote the documentation, and you went back and you wrote the tests, but you already know it works. And if you're pressed for time, you might very well feel like you can skip that particular step, right? Because it's already working after all. That's a bad mindset to get into. So it's much better to write the test first, and then write the satisfying test that satisfy that. Rather than write the satisfying production code that satisfy the test. So now you've got 2 for 1. You've got working code, and you got your dopamine hit associated with getting your code to go green. When you write code in this way, all your code starts with a test. So you know you've got good coverage because you couldn't have written a line of production code without having written the associated test. So you now have a test suite, a harness that you can trust. You can refactor with impunity. You know that you've covered everything, and so when you make changes, you know that the harness will capture everything, right? So you get a lot of benefits from this approach. I think it's worth doing. We at Pivotal, of course, at Pivotal Labs, we do a lot of pair programming, right? Pair programming has a lot of benefits. I could go on forever, but one of the big benefits is this pair programming approach when doing testing. We do red-green refactoring. So somebody writes the test that fails. We write the test that fails, and then the pair writes the code that makes that test pass, right? So you go back and forth, and you can switch roles, of course, right? One person can write the production code, and the other one the test. And you get 2 sides, 2 brains focused on the same problem, and you don't feel like you're stepping over each other's feet. You're actually writing a specification, which is the test, and then you're implementing that specification, right? So a lot of benefits in moving to this approach. I definitely recommend you look into it further, and we're going to do that today. We're going to look at test-driven development, but we're not going to linger too long on the notion of test-driven development. We're going to look at Spring support for testing. So let's create a new project as we normally do here at start.spring.io, and we'll call this Bootiful testing. And we're going to use Spring support for building web applications. We use JPA, we use H2, we use Lombok, and we'll hit generate. Now it doesn't really matter what version of Spring Boot you use. All the stuff that we're going to talk about has been in Spring since, or rather Spring Boot since 1.4, so we're on firm ground, whatever version we use these days. So we'll open up the release. All right. Now we have a new application. And we could start here, but again, we want to write the tests first. So a convenient command here is Control-Shift-T in IntelliJ. It takes you to the corresponding test. In this case, we don't actually want that corresponding test, do we? We want to start with the simplest thing that we can build into the system. So the first thing we're gonna test is our basic entity, our reservation entity. We're not even going to talk about it in terms of entity. We're going to talk about it in terms of the object. We're going to test the soundness of this entity. So I'm going to create a reservation test, and therein we'll test the creation of the object, right? So at test public void creation, right? And I will learn to spell. There we are. And in my object, in my test rather, I want to confirm that when I create an object of type reservation and I give it some data in the constructor, that it does the right thing. So let's create a record of that form. Already our test has failed rather. So we need to actually create this production class. Hit Alt-Enter. It'll create it in the corresponding package. I want to provide values in the constructor. Obviously that needs to be done as well. Now I could create the constructor myself, right? I could say reservation long L, and then string name, right? But what I want to do is actually take a little shortcut here. I'm going to use the lumbuck annotations, and I'm going to take for granted that in this case the state of my object is the same as the structure of my object. So I'll create two fields here: private long ID and private string reservation name, like so. String reservation name, et voila. So there we are. We have two fields. By having the @allargs constructor and the data annotation, I get a constructor that will work here. And of course now I can say r.getID, get reservation name, etc., which lets me write some tests. So I can say assert equals r.getID, and I want to say that it's equal to 1L, right? So I'm going to upcast or promote or coerce that unboxed integer, or long rather, into a Java lang long there, and I'll assert that it's working. So we can run this test now. So let's see, run that code. So that seems to have worked. Good. This is one way to do it. Of course, we could do that. We can use the basic JUnit methods that have been in JUnit since forever and a day. We could also use the assert that variant, right? So assert that, and this expects a object of type matcher. Now, for reasons I don't really understand or even care about, because it's really gross, you're not supposed to use matcher, right? You see that? Matcher has this great method that says don't implement matcher, which of course begs the question, why did you put that there in the first place? I suspect that given the availability of default methods in Java 8 these days, they wouldn't have made that same decision. And for our purposes, we just need to extend base matcher. So you can create your own custom matchers. And the nice thing about this approach is that these matchers can be packaged up. You can package them up and distribute them. So now you can reuse complex tests, complex assertions, and functionality there. And for our purposes, though, we're just going to use some pre-built matchers that more or less mirror the stuff that we would have gotten with basic JUnit assert asterisk methods. These are from a project library called Hamcrest, and there's a number of different matchers here. We can say that we want to assert that the ID is equal to 1L, right? So there's that. Now let's run that code again. Okay, so that seems to be okay. Great. Let's take it one step further. We can use a library called assertj. You see, the test here has a generic constraint, but otherwise it's not really, there's no guidance as to what is an appropriate matcher to put here, given the type here, given the parameter on the left. So the matcher on the right isn't informed necessarily or driven by the parameter on the left. Whereas if you use the assertions library from assertj, you can say r.getID is equal to 1L, right? It kind of auto-completes itself, and so I prefer that, right? Get reservation name. See, that works, but I can see that it also says it's not blank, and I can say that is equal to Jane. So I get this very, very convenient sort of type-safe matching functionality, this test functionality, and the test basically writes itself. Let's break the test here. Let's say that it's equal to Janet, and see what happens, right? the error message is very useful here, right? So you get all that functionality very quickly. All that is nice. Let's close this. Now, I have just used the assertions library, and that's fine. It's also interesting that there's a BDD assertions class in AssertJ, which gives you basically the same functionality but with a then keyword. So you can say given, when, then, using the BDD style of testing, and that's worth your consideration as well if you're doing BDD, which you should be. I mean, there's a use case for that, right? So never say never. But for our purposes, I think it suffices to leave things as they are here. Now, the next thing that we're going to want to test is the JPA mapping, right? So we've got a class, but it's not an entity. We just know that structurally it'll do the right thing. When I give it a constructor argument, it'll pop out given an invocation to an accessor, right? So that's working. We can say reservation JPA test, okay? And there's this, and we can say test public void, and what we want to do is test the mapping, right? So I want to test the mapping here of the JPA entity when it interacts with the JPA entity manager. Well, I could, mock, or I could configure all of JPA and the data source and all that stuff, but I forgot Spring, and Spring already knows about all that wiring. So why would I recreate that? So I can actually use the @runwith springrunner.class, and the Spring Runner is a test runner that we provide in Spring Boot and Spring Framework, and it's a test runner that is, it's a mechanism that JUnit itself exposes, right? This is a thing that's from JUnit, which you can use to tell Spring you can tell JUnit to involve Spring in the execution of your tests and to make available collaborating objects and so on. So that's very, very convenient. You need to give this more information though. This will say activate the machinery required to run Spring, but what application context, what configuration class, right? Lots of things here that are required. There are a lot of things that are required beyond the recognition that we're going to be involving Spring somehow. So we could say @Spring Boot test, and there's a classes parameter or an attribute that is expecting the configuration class that we want to run. We could certainly do that. That's certainly one option. The problem with this, of course, is that the default behavior of the Spring Boot test annotation is to load the entire application context. And all we're trying to do is to test our interaction with JPA. Just the entity manager mapping, right? Just the interaction between the entity manager and the annotations on my entity. So I don't want to start up Tomcat just to test that. I'd much prefer to instead start up a slice of the application context related to persistence and JPA and run that, and then in isolation test the things there that we care about, and then leave out the rest, right? And that was easier to do before in the world of manual configuration of everything with different Spring application context XMLs and configuration classes. You could certainly slice and dice your application in terms of layers, and that was a little bit easier to do because you'd have multiple configuration files, and you could, in your tests, instantiate just one application context XML and ignore the rest. That was certainly an option. I don't want to go back to that, though. I'd much rather let Spring Boot write the configuration for me. I'm very happy with that, and what little is left, I test myself. That said, I don't want to run the whole application just to test a piece of functionality. So Spring Boot 1.4 has this concept of a test slice. So instead of using @Spring Boot test, which is like it's a slice of the whole, it's the slice that is equal to the whole pie, basically. Instead of using that, I'm going to use a data JPA test class. And here I can provide a number of different things. But what this is going to say is, first of all, it's going to do three things. It's going to register. It's going to remove the auto configuration that is there by default. It's going to basically set to 0 all the configuration classes that Spring Boot would normally run. Then it's going to provide some configuration classes that should be run. Then it's going to contribute things that we would need to effectively test this kind of stuff. So including stuff that you wouldn't otherwise get in the auto configuration for the production code, right? This is stuff that is valuable only in a test context. And also part of that, it'll set up some defaults. It'll set, for example, that the test methods here are transactional, right? So you can see here that there's a lot of stuff happening here. It says this is going to be it's going to override auto configuration, It's going to exclude certain classes from the application context. We're telling Spring, don't bother with certain types. Just ignore them. Pretend that they aren't registered. We don't want them in this code base anyway. And we're going to tell it to auto-configure certain things. And these annotations also have attributes that are mapped sometimes to properties. So, for example, let's see. Going back here. There we go. We can see that the cache provider attribute for the auto-configure cache is mapped to the Spring Boot property file in a value called spring.cache.type. So if you, in your test folder, have an application.yaml or application.properties that has spring.cache.type equals whatever, it'll be set on this annotation and used to inform the behavior of this test only in the test code, right? So you get a lot of nice benefits here. You'll also notice that we have this, we looked at this before, we have this override auto configuration. This tells Spring Boot rather, that, oh, and by the way, we also have other properties here, I just saw that, spring.jpa show SQL is equal to true, right? You could override that, but it's equal to true by default, so you'll see later on when we use JPA that it's going to show us a DDL that's used to create the entities. One thing that's nice about this overriding auto configuration is that we're telling Spring to set, to remove all the auto configuration and then let us recreate from zero the configuration required to do JPA and to test in that world. We can provide our own auto configuration as well. So we can say in our own spring.factories text file in the meta-inf directory, we can create our own text file that has the name of this annotation, org spring framework boot test orm JPA, data JPA test equals, and then our own auto configuration, so that whenever we use data JPA test, our own auto configurations are involved as well, going beyond what's happening here. And this whole mechanism, by the way, of course, is completely reusable. You can create your own test slices. Perhaps you've got some aspect of the application that should be tested in isolation, independent of the default configurations in Spring Boot, and you can absolutely do that. You can package it up as a test slice annotation like this, and then distribute that. And that way, there's a go-to reusable mechanism for instantiating just the bits that you care about when you test. Let's see, what else do we care about here, huh? We have excluded, we have the inheritance, we've got the auto configuration. What do we have auto configured here? This stuff makes a lot of sense. This is just basic Spring Data JPA. Of course, that's going to work as we expect. Here's the cache support, but this is going to create a test database. So in my build, I have a Spring Boot starter data JPA, and it has a H2 database here to work with, right? This is a default convenience. You see me use this a lot in various Spring Boot videos. I use H2 because it's embedded, it's in memory, it's easy to stand it up. I don't have to configure a data source. I don't have to have anything running on my local machine, which by extension means that you don't either if you want to play with the code. But the underlying assumption, of course, always is that you're probably not going to use that in production. You're going to go to application.properties and say spring.datasource.password or username or URL or whatever, and point it to something real, like a MySQL or Postgres or Oracle or whatever, right? SQL Server, anything these days. And you can certainly do that, and you probably will, right? That said, that's not going to be what you test against, is it? I don't expect you to test your application against your production Oracle database. That would be crazy. So instead, you're going to want to mock out or at least point to a different data source. And you can do that by overriding the properties. But that gets to be very tedious. You have to now involve your Oracle installation somewhere just to run your unit tests. And that's even more grating because we don't care about Oracle at this point. All we're trying to prove is that when I map my entity, that JPA knows what to do with it. That's it. That's all we're trying to prove here. We don't need the database for that. We want some database. We want something there, but really we're just trying to prove that we've got the right mapping annotations in place. So that's a layer below us that we don't care about, and I want to mock it out, or at least I want to not care about it. And that's what this annotation is going to do. It's going to create a in-memory H2 database for us. Even though right now my application is using H2, I could say use Postgres. This would still create an in-memory H2 database for us in the test context. So my reads and writes are all to this sort of in-memory ephemeral database that makes it really, really quick. We're also going to auto-configure a test entity manager. If you've ever dealt with a low-level JPA persistence context annotated entity manager, then you know that entity manager is a generic, friendly version of the Hibernate session, basically. And it's very low level. And if we're trying to do things with testing, then the use cases, the patterns in testing are going to be different from the interactions you might expect when you write production code using the entity manager. So this creates a new object. It contributes a new object that's useful only in the context of testing. And that object is called, guess what? Test Entity Manager. And it provides some convenience methods. So we'll take advantage of that as well. So here we go. We've got our mapping. I'm going to auto-wire the Test Entity Manager. Right, TEM, there we are. And we're going to use that Test Entity Manager. We're going to say this.tem, and we're going to call persist, flush, and find. So this is going to be a threefer. It's going to write the record to our in-memory database, the test database that we have. It's going to flush the session, and then it's going to retrieve the record by its ID, all in one fell swoop. So we can prove exactly what we're trying to prove, which is that given a new reservation, of the following form, null and Jane, that we get back a record that we expect. So there's Jane. We're going to say assertions dot Jane dot get reservation name dot is equal to Jane. Good. And I'm going to say get ID is not null. Right? So there's that as well. So we've got these two different methods. We're going to say that reservation name is equal to Jane, and the ID is going to be not null. We also want to say that the ID should be greater than, for example, 0. Right? That's a truism for our primary key here. All right. So let's see what that code looks like. Let's run that code. And of course that failed because we're testing the wrong thing. First of all, I forgot to undo the old test. So I'm glad we reran that so we can fix it. So let's see. Reservation JPA test, and that's this one. Reservation test. We broke this earlier just to prove what would happen, and I forgot to restore it. All right, that's this. And now the mapping, we're going to test by running it instead. Good. Now that's fine. Now we run this, which is the mapping test. Okay, so that broke, predictably. It's saying that we have an unknown entity. That's fair enough. So let's go back to our entity and bring in the JPA entity annotation, and we can run that same code again. Mapping now breaks a different way, I would expect. Yep, no identifier specified for the entity, so at ID, at generated value, right, there we are. So let's run this one more time. All right, so that seems to be good and green. Moving up, let's now test the repository. So we're going to say reservation repository test. And what we're trying to do here is to prove that our custom finder method works, right? We're not going to test the repository itself. We know that Spring Data works just fine. I don't need to prove that the find all method and save method and all that stuff work as expected. That's been tested time and time again by innumerable many other people, and we don't have to worry about that. That's the benefit of building on a framework. But if we customize the repository and provide custom finder methods, it can be useful to validate that that's working as we expect it to. So let's do the same thing as we did before. Public void. We're going to test the find by reservation name method, and this will of course use the Spring runner. So run with Spring runner dot class, and that'll be of course a data JPA test. There we are. Good. And we're going to inject our reservation repository. All right, there we are. So that repository doesn't exist, of course, so we'll create that. Otherwise we have a failing test. Okay, and we're going to use the repository. We're going to say this.repository.save. Of course, we can't save a new record until we have the save method, so we're already at our first failing test. Let's fix that. All right, Alt-Enter, create this method. We could do that, but of course, we both know that Spring Data will do that for us, so we're going to say at JPA repository, reservation managing entities of type long. There we are. And that'll give us a saved record in the database, and we should be able to, based on that, use our repository to find by reservation name, passing in Jane. Now, of course, this method doesn't exist, and that's a far more problematic one. We have to actually implement that one. That's the thing that's going to be under test, right? So here we are, reservation, string, there we are, name, there we are, there's a custom finder method. Our test now should return a collection of, by reservation name results. And we can say assertions that by reservation name dot size is equal to 1, right? Remember, we're using a test database, so there's no more than one record in the database. And we want to say that the iterator dot next dot get ID is greater than 0, and we're going to recreate the iterator so we'll get the same record back again. And we're going to get now the reservation name. I'm going to say that that is equal to Jane. All right, so let's now try running that one. Find reservation name. Good stuff. All right, so we now have a test that proves that our interaction with the repository is working as expected. We can see, by the way, of course, the DDL. I mentioned that would happen earlier. We can see the DDL reflected in the console here. And so we've tested every layer. Now let's build a REST API. Let's test the REST API that we're going to build first, of course. So we're going to say reservation REST controller test. And here, instead of using the test slice supporting data access, we're going to use the web MVC test slice. So we're going to use that and the spring runner.class. All right. And the web MVC test configures for us the cache support, the web MVC support, mock MVC, and excludes certain objects that we don't care about, including those, by the way, related to persistence. So this isn't the right tier to test persistence logic. And we've already done that, so we want to take that for granted. So we're going to take advantage of the pre-configured mock MVC client, right? That's what's been configured for us. And we're going to create a new test, public void get reservation. So we're going to prove that, given a request, that we get the right response. So mock MVC perform mock MVC result matchers dot status dot is okay. So sorry, we have to do this correctly. Result request builders dot get reservations. There we go. And expect that it's okay, right? Now we add the exception. There we are. There's our simplest test. That's as little as I can write to fail. All right. Now the mock MVC client here is a sort of an engineered agreement between the REST framework. The framework is Spring MVC, of course, and the test code here. We're not actually creating real HTTP calls. There's no socket open here with HTTP payloads going across the wire. What's happening is we're making requests to the service from the client, but the client is talking to Spring MVC itself, not to Tomcat or something like Tomcat. There's no server socket listening for requests. So this is going straight to Spring MVC. Spring MVC is processing the request as though it were an actual request from the web. It's going through all of the processing phases, going through the HTTP messaging translation and the message converters, the validation, the all that stuff to do with processing of a request after this Tomcat has turned it into a HTTP servlet request, right? All that stuff is being done for us just as though we had actually issued the request. But the benefit is that we're not starting up Tomcat because we don't care about Tomcat. We know Tomcat works. So let's get this basic test to work. Let's go ahead and go to our reservation controller. And again, very convenient. We can go here and reservation REST controller. Reservation REST controller. And we'll say at test. Okay. Oh, sorry. We're not going to say at get mapping. And it's going to be a / reservations endpoint. And all we're going to do is return an empty array list, right? So collections dot empty, and we'll say at REST controller. There we are. So we'll go back to our test here and run this again. Good, that passed. Let's do something more substantial. We'll say also that we expect the content type to be equal to application JSON, like so. Restart this. All right, that seems to be working. Good. Let's now do something just a bit more substantial than that. We'll actually poke at the result that comes back. So mock MVC result matchers dot JSON path, and we're going to say at.0.id is going to be equal to 1L, and we're going to say that the reservation name, again, I'm writing 2 tests instead of 1, I shouldn't do that, is going to be equal to Jane, and we'll run this again, and that should fail substantially, right? All right, so we know that there is no value at that JSON path expression. Here we're using the JWay JSON path matcher, right? So that's supported for us. We don't have to import anything; it just works. And we need to actually configure. We need to respond with data in the response, and we can do that, of course, by injecting the repository. So we say private final reservation repository, injecting that into the constructor, and then here we'll say return this reservation repository find all. Now, if I go back to this test, what do you think is going to happen? It's not going to work. We know that, right? All right, see that? It says no such bean definition exception, no qualifying bean of type com Bootiful testing reservation repository available. That's because it's been excluded from the application context, and that's by design. The last thing that we want to test is our database layer. We're not trying to test that. We know that that works. We've already done an extensive amount of testing at that layer and below it to prove that that works. So instead, what we need to do is to mock out the reservation repository. We have to tell our risk controller to use the reservation repository, but we're going to give it a fake version of that object. We know that's an interface, so we can provide any implementation that we want. And this would be possible. You could contribute your own custom configuration class, right? I could say, let me see, can I do that? I can say, I guess I can. If you're using Spring Boot test, you can provide your own custom configuration class. I think you can actually say just my config and make this a configuration class, and then provide your own bean of type reservation repository. I guess that's an option. Let's see what happens if we do that, right? So Mockito dot mock reservation repository class, and this will give you a response. And what we're going to say, Mockito dot when mock dot find all dot then return arrays dot as list new reservation, and it'll be 1L and Jane, right? I think that'll work. So let's see, return mock. So that usually works. I know you can do something like that with the Spring Boot test framework support. Does that work? All right, the content type has not been set, so we're losing for different reasons. Let's try fixing the risk controller here. Produces media type application JSON UTF-8 value. Okay. Content type is not set. Well, that doesn't make sense. I'll bet that this is to do with my clumsy mocking of the object here. And that's okay. That's actually just fine, because this isn't the right way to solve it anyway, is my point. What we need to do is to mock out that object and replace it with a MockBean, right? So we could attempt to carve it out ourselves and provide a custom configuration class, and that as you see, I'm not sure if it's even possible in this particular configuration, and either way it's the wrong way to do it. Instead, we can take advantage of an object called MockBean, or an annotation rather, called MockBean. What this does is it provides you with it tells Spring that this type should be contributed to the application context if it doesn't exist, and if it does exist, it should be replaced with this mock object. So here we're going to contribute a bean of type reservation repository that's going to be a mock. And how's the mock going to be created? Well, it's going to use Mockito, just like I tried to do a minute ago using that custom clumsy configuration class. This mock will, now when Spring starts up, it's going to inject this reservation repository. This will work. It'll get as far as the constructor. This pointer will be to a mock object, and everything will be just fine until we get to this line where we try and return the data from the find all method. That's not going to work, of course, because a mock, by definition, is an empty object. It provides stubs. It provides default values, nulls and zeros and false. Right? It provides as little as it can, and it's basically an empty husk. It's going to it'll help us get past the construction phase here. But if we need to do anything more than have a stand-in just to take up a space and get past an occasional assert not null call, then that's not going to work. What we need is a stub. A stub is a mock that has pre-programmed behavior. So here we're going to go back to our reservation REST controller test, and we're going to say makito.when this .reservation repository .find all, then return collections.singleton list new reservation. So here it's going to be 1L and Jane, right? So we've got, we're going to pre-program it with an empty, almost empty list, just with one value, and we're going to run that test again. All right, so there you go. You can see that works. We actually got back the response that we're expecting. The content type is equal to or compatible with application JSON UTF-8, and our application is now fully tested. So if we go to the command line, cd downloads Bootiful testing maven clean package, you can see that the tests are fast, they're clean, they're green, and we should have now a working Spring Boot application. Now, the concepts that we've looked at here are the foundations upon which concepts like consumer-driven contract testing rest, and we've looked at that at least a little bit. We looked at that in at some length in an earlier installation of Spring Tips, where we looked at Spring Cloud Contract and its support for mocking out HTTP services. There's more to discuss there. We could talk about messaging, for example. This also leads us very nicely into another discussion of JUnit 5. So JUnit 5, of course, is a different programming model. It's not backwards compatibility. It's not very backwards compatible. That said, it's easy enough to get to move code to it, and it is a very, very powerful paradigm. It gives us a lot of benefits. One of which, of course, is that I don't have to use auto-wired private fields like this. I can actually have constructor injection in my tests. There's a number of other things that are very compelling about it. And for the most part, the Spring testing apparatus works just as well. We don't use the run with annotation anymore. That becomes an extension in JUnit 5 Jupyter world. But it's definitely worth looking into. So perhaps that'll be the topic of another Spring Tips installation at some point in the future. All right. So with that, my friends, thanks so much for watching, and we'll see you next time.